we're going to learn algebraically one technique how to solve, and then on Monday we'll learn the other one. So today is we're learning by substitution. So we're going to solve this system: 2x plus y equals 3, and 4x plus 3y equals 5. So the first step, I think you guys like steps on how to do this, so then when you go to your homework you can actually follow them. So you should be solving for one variable. Okay, so if I look at these two equations, it doesn't matter which equation, which one would be the easiest variable to solve for in your opinion? The first one, solving for y, yeah. Because all you have to do is one little step, move it over, yeah? Okay, so equation 1, we are going, and I'm going to label it still number 1 here. I'm going to solve for y. So now it's in the form y equals what? If I move, yeah, negative 2x plus 3. So now what we're going to do is we are going to substitute, that's why I call the substitution method. We are going to substitute this expression into the other equation for that variable. So do you see, we have established that y is negative 2x plus 3. We're going to take that and substitute it into equation 2. So equation 2 is now going to be 4x plus, now instead of 3y, we're going to write 3 bracket negative 2x plus 3. Does everybody see what I'm doing? Equals 5. Okay, so instead of this y here, I'm putting the expression for y in there. So do you see now this is like a grade 9 math algebra question, right? So what do we do to solve it? Yeah, multiply this in now. So I'm running out of room, so I'm going up here. All my arrows everywhere. 4x minus 6x plus 9 equals 5. Is everybody good with what I did? Okay, I'm going to combine like terms. So that is minus 2x plus 9 equals 5. Yes? Move the 9 over. I get negative 2x equals what? Negative 4. So what does x equal? 2. Positive 2. And I'm going to circle that. So now I've done step number 3. I've found the value. Sorry, I've substituted. I'm done step number 2, sorry. I've substituted and solved. Now I'm taking this value and substituting it back into that equation that I had solved for y. So it's kind of like you keep on substituting. So I'm substituting it into y. Y equals negative 2. Now instead of the x, I'm substituting 2 in plus 3. So then I get negative 4 plus 3, which gives me negative 1. So that means my solution, therefore my solution is 2 comma negative 1. What does 2 comma negative 1 represent again? Besides a coordinate. In this system, what does it represent? Not the intercepts, the intersection. Yeah, it's the point of intersection, right? When I say intercept, that means x and y intercepts, right? Intersection, this is the point of intersection of the two lines, right? Okay, and how do I verify this? Put it back in. So my verification, remember, my verify, I always go back to my original. This is how you get 100% on the test, right? So it's going to be 2 times 2 minus 1 equals, does that equal 3? Looks good to me, right? 4 minus 1 is 3. And then we're going to put it in the other one. 4 times 2 plus 3 times minus 1, does that equal 5? Well, that's 8 minus 3. What do you think? Yes. All righty. All righty. Okay, in your opinion, which variable in which equation is the easiest one to solve for? X in the first one, I agree. So I know we don't usually have it in x equals form, but in this case we are. We're going to have x equals what? Yes, negative 3y minus 2. So I'm going to circle that, and what do I do with that? Put it into the other equation, not for the y, for the x. Do you see? I'm substituting x for this. So it's going to, instead of this x there, I'm going to put that expression. So so now this is number 2. So negative 3 times negative 3y minus 2 plus 5y equals 6. So multiply this in. I get 9y plus 6 plus 5y equals 6. Yes? So it looks like 14y plus 6 equals 6. Yes? Move the 6 over, I get 14y equals 0. Divide by 14, what do I get? Y equals 0. Now what do I do with that? Yeah, put it back into that first solved one. So now I can figure out what x is. So x equals negative 3 times 0 subtract 2. So what is my x going to be? Negative 2. So therefore my solution, my point of intersection, right, is negative 2 comma 0. And what are we supposed to do after we figure that out? Verify it. And you might ask, do I get points for verifying? Not unless the question actually asks you to do it will you get points. Otherwise, you're just doing this to assure that you did it right. So let's see. Negative 2 plus 3 times 0, does that equal negative 2? Yep. And then negative 3 times negative 2 plus 5 times 0, does that equal 6? Yep. So then that is my correct solution. So what do you think about this technique? Not bad? Very algebraic, like you're solving, right? Okay, do you guys want to try the next one on your own? Yeah? Okay, which one would you solve for? Probably x in the first. Okay, so I'll let you do that. But she verified it, so let's do this. So this one is probably the easiest one to solve for. I can move the x over to the right side and the 1 over, so then I get x equals 2y minus 1. Everybody see my fast maneuver there? Technically, I moved the negative x over to the right side and the 1 to the left, but then just rewrote it on the left side. It's all legit, okay? So now I'm going to take that and I'm going to substitute it into number 2. So 3 times 2y minus 1 plus 3y equals negative 12. Multiply it in, I get 6y minus 3 plus 3y equals negative 12. So 3y minus 3 equals negative 12. Add 3, I get 3y equals negative 9. And then y equals negative 3. Then I take that, sub it back into there. I get x equals 2 times negative 3 minus 1. Oh, right back here. Oh my gosh, it is 9y. Shoot. Okay, 9y. Hold on. Then I get 1. Thank you for catching my error there. Okay, so then I'm putting negative 1 in here. Because I was just going to say I wasn't going to get the answer you guys said. And I get negative 3. All right. That was a big oops there. So my solution is negative 3, negative 1. So let's verify. Verify. Okay, so negative 3 plus 2 times negative 1, does that equal 1? Well, this is 3 minus 2, so yeah, that one worked. And then 3 times negative 3 plus 3 times negative 1, does that equal negative 12? So that's negative 9 minus 3, so yeah, that works as well. So, okay, let's try the next one. I'll give you a second. Actually, the next one is nice, hey? It's already solved for a while. The first step's done for you. Do you see that? Okay, I'll give you a second. So it's nice they've already subbed it in for you. So I'm subbing that into that. So 3x minus 2 times x plus 6 equals negative 13. Multiply that in. I get 3x minus 2x minus 12 equals minus 13. So I get x minus 12 equals minus 13. So x equals negative 1. Take that, sub it back in there. I get y equals negative 1 plus 6, which gives me 5. So my solution is my solution is -1, 5. I'm going to verify it because that's a good habit to verify. So 5, does that equal -1 plus 6? And I would say yes. And then 3 times -1 minus 2 times 5 equals -13. So that's -3 minus 10. And that works as well. Very good. So now we're going to go to word problems, it looks like. So again, the hardest thing is coming up with the equations. Okay, so create a linear system to model the situation. Make sure you tell me what the variable represent. So tickets are sold for the senior safari day at the Greater Vancouver Zoo. Meryl buys 5 admission tickets and 3 train tickets. She pays $65. Howard buys 2 admission tickets and 1 train ticket. He pays $25. What is the price of each type of ticket? So what am I going to actually make the variable then? So we're going to let A equal what? Don't say admission ticket. Is it the number of admission tickets? The price of the admission tickets? I don't think it's the number of admission tickets. Because it says here he bought 5 admission tickets. So I know that together they had 7. It's the price of the admission tickets. So the price of admission tickets, and what are we going to let the other variable be? T. And that is going to be, again, the price of train tickets. How do I know it's that? Because it pretty much somewhere in the question asks you, so what is this, right? And then so it doesn't say, you see it says, what is the price of each type of ticket? So you knew you were solving for the price, right? Okay, who can come up with Meryl's one? Jackson? Very good. Okay, who can come up with Howard's equation? Fabia?
2a plus t equals 25.
Very good. Okay, so I'm going to label this equation 1, equation 2. You don't have to do that, but I am. Which equation is the easiest one to solve for a variable? 2. And what am I going to solve for? T. So I'm going to take 2 and say t equals what? Yeah, -2a plus 25. And then what am I going to do with this expression here? Sub it into the other one. Do you see that? So then I get 5a plus 3. Instead of the t now, I'm writing -2a plus 25 equals 65. So multiply it in. I get 5a minus 6a plus 75 equals 65. So minus a plus 75 equals 65. So minus a equals minus 10. So a equals 10. So now what I do with a equals 10? Sub it into that one there. So then t is going to be -2 times 10 plus 25. So -20 plus 25 is 5. Now this is not a point of intersection. It is if I were to graph it, it was a point of intersection. Because this is a word problem, we're not going to put the final solution as a coordinate. We are actually going to answer the question. What is the price of each type of ticket? Therefore, the price of admission is how much? $10. And the price of the train ticket is $5. All right, so this is my final answer this time. Okay, I'll give you a second to do example 6. Okay, same thing. You need to make sure you're very specific on what the variables stand for. U is, what did you do your variables?
I used S and W.
So S and W. So what does S stand for? Okay, so the number of short answers, because you see short answers could have a different values and stuff, so you need to be specific. So this is the number of short answer questions, and W stands for the number of word problems. Okay, so who can give me the first equation? Melissa? Doesn't matter.
Oh, okay. I used W equals negative X plus.
No, that's probably not your original equation. That's probably your solved one. So try again.
Oh, just S plus W.
Yes, S plus W equals 11. Jackson, do you have the second one?
2S plus 4 times equals 30.
Very good. Did everybody get that as their equations? Okay, you guys are doing pretty good, because usually that's the hardest thing, is coming up with the equations. It's not the solving part of it. So I assume then you solved for that one, because the variable is the easiest one. And so how about Eric, what did you solve for here? You did this one? So just tell me what it is. Yeah, which one? Just tell me what. Liam, do you want to help? Did you do W or S? It doesn't really matter. They're both. You solve for W, so W equals negative S plus 11. Okay, thank you. Okay, I'm going to circle that. You don't have to. You could do S equals negative W plus 11. It doesn't matter. So now I'm going to substitute that in. So 2S plus 4 times negative S plus 11 equals 30. Multiply it in, yes. 2S minus 4S plus 44 equals 30. Minus 2S equals negative 14. S equals 7. Then I do what with that? Plug her back in. So W equals minus 7 plus 11, so then I get 4. So then I can verify it, and then I need to actually write it out. How many short answer questions and how many word problems were there? Therefore, there were 7 short answer and 4 word problem questions. Does everybody understand if it's a word question, you need to write a word answer? Yes?